Hello and welcome to TJC Physics. This series of videos is going to introduce some of the concepts of waves. Waves are an extremely important part of physics, and in Physics 1114 and 1118 classes, we really start to introduce this topic. So if you haven't watched any of my videos before, what these are basically meant to do is supplement a lot of the class material and things we do in lecture in my Physics 1114 and 1118 classes. But if you need to do some extra review or you have some time while waiting for the bus, these bite-sized videos are sort of meant to just kind of refamiliarize yourself with some of the material we learned in class. In case you're wondering, the simulation you're seeing on the screen is from PHET, P-H-E-T. It's a website that has all sorts of physics simulations on them that are free to use. I highly recommend going and checking them out, as you may find them very helpful when learning physics. Anyways, I've screen captured from that site. I'll include a link in the video description. In my introductory courses, we generally concentrate on mechanical waves, which are waves that have to travel through some sort of substance or medium. This requires there to be a disturbance. That disturbance will then propagate through the material or medium to another location. So waves provide a mechanism to carry momentum and energy from an initial disturbance and spread it out through space. Examples include sound waves, water waves, seismic waves, any other type of pressure waves, or even something like plucking a guitar string is an example of a mechanical wave moving through the string. Later on you learn things about electromagnetic waves, which are light waves. They are different because they don't require a medium to travel through. So since we're going to deal with these mechanical waves, it turns out mechanical waves, like sound waves or seismic waves, as I said before, travel through the medium in two different ways. The first type of mechanical wave we'll look at is a transverse wave. A transverse wave is one in which the particles that make up the medium move or oscillate in a direction that's perpendicular to the direction the wave is traveling. So if you see on the screen, marked with little green dots, you can see the beads on this string are moving up and down while the wave is moving to the right. This is called a transverse wave, and transverse means at 90 degrees. A second type of mechanical wave is called a longitudinal wave. I'm showing one in the simulation above. I'll include a link to this simulation in the description of the video because it is kind of cool and I want the person to get credit. And this is a situation where the wave goes through and makes the particles of the medium oscillate back and forth along the same axis that the wave travels. So if you think of those little dots as air molecules, for instance, and you push on them, then those air molecules, when they get pushed, bounce into the air molecules next to them, which then pushes them into the next one, and so on. And this is what you get a longitudinal wave. I've also switched the view up so you could view it as little lines. So you can see, for instance, the wave moving through and some of the wave pulses moving through that way. I'll also include a bit of footage I tried to do of a slinky where I put a longitudinal pulse through it, and you can see parts of the slinky vibrating back and forth. But once again, the particles never have a net displacement, but they move back and forth along the same direction the wave is traveling. Now, whether the mechanical wave is either a transverse wave or a longitudinal wave, it turns out the same quantities and mathematics can be used to describe both. And since a transverse wave is easier to draw and visualize, especially with some of the apps that you can find online, then we are going to stick with just going the rest of our videos on waves using transverse waves. But please note that the same mathematics and principles apply to longitudinal waves as well. By the way, many complex waveforms, such as those like water waves crashing on the shore, are usually a mixture of both transverse and longitudinal waveforms. We're not going to worry about them too much in this course, though. We're going to try and keep it simple. So that's a brief introduction to waves. In following videos, we'll go over the various quantities that can describe a wave, and we'll see how we can solve some problems with it. Well, thank you for watching, and please feel free to subscribe to the channel and look for more videos soon.